Hi, coming to you from the Math Clinic. This is Dr. G, and today we're gonna look at counting and the fundamentals or the fundamental skills that are required for our young learners to perfect in order to go higher and higher. So we're trying to do this the right way rather than a route method or so. We want to look at full comprehension. All right, so now this idea, a number, really is just an idea. And I mean, it's really amazing that our students can look at the numbers 1, 2, 3, etc. And they have to have the ideas of what these numbers convey. I guess I should also put in 0 in there. And so counting and the permeation of this idea of a number, we need to look at what it means in many forms. And you have been probably doing that from kindergarten. You've looked at using objects, so we have a visualization of what a number is. You have the symbolic representation, which is what I've written over here, right? And we are going to use them and put them, of course, together in many different ways. So let's get started. All right. So the essential skills that you must have is that your child needs to know how to count forward and backwards by 1, starting at 1. So 1, 2, 3, 4, 5, 6, 7, if they 8, 9, 10. And depending if they're in kindergarten, they will probably only go up to 10. By first grade, it's about 20. And second grade, we can even go all the way up to 100. It depends on your curricula. And not only should you be able to move forward, but you need to be able to move backward. So counting down, if you're doing only 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So if your child has mastered that, great. The second thing that many people neglect, unfortunately, is this idea of starting to count forward and backward at any number. So if I started at 8, 9, 10, 11, 12, I got all the way up to 20, and then I could come back down, 20, 19, 18, 17, 16. Now, I'm doing it quickly because I'm an adult. Be aware your child is going to pause, might make some errors, and so on. Right? So don't be put off by that. It all depends on the age of the child, number one, the exposure of the child. So somebody could be even a grade 8 student, but they had a delay in their either schooling or formal schooling or not, speaking, etc. And so this could slow down their response. So, but as long as we have a firm foundation, we'll be able to move ahead. All right. So continuing on in this little video, what I'll be doing is we'll be looking at visualizing numbers and the physical models, many of which you've seen already, building a number sense. You might not quite understand what that means, but I'm sure I'll explain it. And what we call the 4 fact families, and we're starting with addition and subtraction. There'll also be 4 fact families for multiplication and division. All right. Now, initially, with your child, the idea behind this is that this video can be extended, but we're going to start here mostly with working with sums, first of all, sums and differences, but sums that are less than or equal to 10. And then we'll move on to things that sum over 10. Okay, so here we have a typical setting. I have 2 groups, all right? So we have this situation, a drawing, especially if your child is in kindergarten 1, 2, even 3, they'll still be seeing these visualization. Now, But the idea, what I want to get across is what is the concept of addition? Many times we don't think about this. And the concept of addition is put in two groups or put in groups together, right? Groups together. And so we have to have this idea of addition. Now, build in this number sense. Many students, if I put this up either on my table or so, they'll tell me the answer right away. And you will give me a solution. A solution is nothing more than the answer. But if I asked you, even as adults here, what do you mean by, given this scenario with the coins as shown, what would you write, or what am I talking about a number sense? Well, hopefully you would say, oh, I'm adding, I'm putting two groups together, then the sum. So let's put some words here. These individual parts are called addends, right? And the result is called a sum in this case, right? So the result of addition is a sum. And it's important that we get used to words, all right? Mathematics is not just symbolic language. It's not just me having 5 plus 3 equal. This is what we probably focus on, but there is more to it than that. So the number sense is given either these problems, whether visualization, a model, right, physical model here, or given the abstracted symbols, abstracted ideas of numbers, we should have a number sense for this particular problem that the solution, right, the solution must be greater than 5, right? Because if I'm putting two groups together and combining them, it cannot be smaller than the larger of the addends, or the larger of each group. And so we want to, as we go through with our younger kids, ensure that they have this idea of the number sense too, because it's not just the solution that you want to impress upon their mind. It's not all about the answer, at least not in my class. All right, so oops, I guess I put that up again. So we had 5 plus 3, and of course, if I put the group in, here you're seeing, here's my first set of items, here's my second, I can clearly count 1, 2, 3, 4, 5, 1, 2, 3, and if I put them together, here's my sum, and I can clearly see that they're 8. Do have your child use models. Depending on the age of the child, we don't want them, you don't want to leave them alone and they put items in their mouth and we end up with a choking hazard. So either use items that are larger and that won't create this choking hazard, or be there with your child as he or she is working with these, particularly on the very young stage. If you prefer, why not use playing cards? Well, here I'm using the ace as 1, and here are 3. Might be a little confusing for the very young kids because as you can see, it's not just counting the 3 little hearts here, but you have some more stuff. They might get a bit confused. So this might be left to the grade 2, grade 3, grade 4 children. All right. But again, putting things together, you can have your child. Math should be about color, should be about, making, drawing, being a part of the process. So I have my 3 items. I'm grouping them together. I create 4 items. Okay. What else? Now, this idea also of grouping and putting together, well, hopefully we can look. Suppose I change the order. Let's go on back here. Here we have another. All right, so I'll just continue with this then. Here we have another use of models. You probably have or can find in any toy store lots of dye. If you can get colored ones, that's even better. And the child can see the model, give you the answer if you haven't provided it, and, write out symbolically what is going on. Okay. All right. Now, let's look at the opposite of addition, which is subtraction. If I have 8 minus 3, again, I'm going to ask, what is the concept of subtraction? And hopefully you can tell me that the concept of subtraction, it is to break a group or break up a group into parts. So here I have a group of 8 and I am removing 3. So in removing these 3 items, I'm now left with 5. Right. So some of these, I'm not just interested in the answer or the solution. I am also interested in knowing or understanding what's going on. What's the number sense? The number sense is that if I'm given 8 minus 3, then it cannot be more the solution. The solution cannot be or can't be more than 8. Right? It can't be more than 8, what we started with, because I'm going to be removing that. That's the maximum I have, and I'm going to be removing things. So do check if your child understands some of these concepts. All right. I had mentioned earlier about the fact family. So let's take a small example. If I should give you 2 plus 5, or let's start out of 2 plus 5. Here are the fact family. There are four statements that make up a fact family that you can check if your child understands. So 2 plus 5, the add-ins are 2 and 5. This is a grouping together. It must be, I can look at it, 2 and 5. It must be more than 5 when I put them together. So it cannot be less than 5. We end up with the answer 7. Whether the child is using his or her fingers at the stage, or I'll show you another method. So here was the first statement. This was what you were given. 2 plus 5 equals something. The second fact family is that I could change it around. 5 plus 2, right? So if I have a group with 2 items and a group with 5 items, I ended up with my 7 items. 5, 6, 7. Right, and it didn't matter if I exchanged these groups, I had the same amount. Right? So this, believe it or not, is not an automatic concept for young kids to get. So be patient and actually use the models and so on. Right? Now, when we have a fact family and dealing with addition, the reverse or the opposite of addition or inverse of addition is subtraction. And so if we took the sum that we had, the big group that we had, and we said 7, we're breaking it up. 7 minus 2 would be 5. But likewise, 7 minus 5 is 2. So your child needs to be aware that you could have started with the group, and if I now removed my 5, I'm working backward. If I took out 5, then 2 would be left, or vice versa. If I covered the region that had 2 items, then 5 would be left. Okay, so this is the idea of a fact family. Start out with your child with things, I still even want to say 2 plus 0 is 2, right? And make the fact family that goes with that. Turn it around, which is called a commutative property, but I won't hold that against you yet. 2 minus 0 equal 0. 2 minus 0, I think I'd be fired there. 2 minus 0 is 2. And the fourth family, let's go back up here. All right, so we had the original statement, 2 plus 0 is 2. Turn it around, 0 plus 2 is 2. 2 minus the one of the addend, 2 minus 0 is 2, and then 2 minus 2 is 0. So here we have the fact family for the first statement. Try to work with your child and let them see practice over time, right? And for all the numbers between, 1 and 10. So work on 10 up to 10s. And so we'll do, let's say if we had 7 plus 3 is 10. Right? You want all the numbers. 8 and 2 is 10, etc. Right? So again, here, let's do it once more. Turn it around. 7 plus 3 is 10, but try to see if the child would now remember that even in turning the order, neither of these, when we look at the addends, the sum must be greater than 7, right? Because that was the larger of the two addends. Going on to the subtraction, 10 minus 7 is 3, and 10 minus 3 is 7. You're breaking up this group of 10 first by removing 7 items from it, and you're left with 3, and so on. As your child gets over or has mastered particularly the sets of, or what we call friends of 10, right? So as your child gets into friends of 10, every combination of 2 digits that sums to 10, then you may go over to look at sums that will end up being greater than 10. So you might have 7 plus 5. They might think about it a bit. I'll show you how we will do this a little quicker. So they get 12. Particularly, as I said, they are over in grade 3, 4, and above, right? So, and we would turn it around. Same idea is present, right? 12 minus 7 is 5, and 12 minus 5 is 7. You might, if your child is just at the stage where they're mastering friends of 10, you might want to hold off on looking at the 7 and 5 or things that are greater than 10, the sum being greater than 10, until you view the rest. So if I gave a student 3 plus 6, especially if they're still using their fingers. So what I would like them to be doing is saying something like this. The sum must be greater than 6. Now remember I told you that we needed to learn how to count from any number. All right? So they should be thinking, 1, that this answer is greater than 6. That's my math symbol for greater than. 2, since they know how to count from any number by ones, they would say, aha, it is greater than 6. I will put up my fingers, right? I'll put up my fingers, but I'm counting from 6. I'll actually put up my fingers. I'll put up 3 fingers. And I will then count 6, and with my 3 fingers that are up, my bad drawing, then I would count 7, 8, 9. All right, so we would have the sum of 9. But what this does is it allows the student to not have to sit down, start counting from 1 and go 1, 2, 3, then putting up six more fingers, 1, 2, 3, 4, 5, 6, 7, 8, and counting all the way up to 9, right? So in their head, although they were given 3 plus 6, the first step in their head was to say, oh, this is the same as 6 plus 3. The order doesn't matter. I'm using the idea of a fact family. And then, in order to go on to the next step, I'm going to start counting at 6, or I say 6, put up fingers, right? And I've put up my 3 fingers, and I then count off. Right? So 6, 7, 8, 9. And so the result, or the sum, is 9. So there's my student putting up his fingers, and he actually counted off by 9 and got his 9. So let's look at some precautions that you have to be aware of when working with your child. Right? Be mindful of no child wants to get anything incorrect, particularly in front of a parent or a caregiver. So you're going to see, or initially you might see some stalling, hesitation, using of fingers. Remember, the whole idea behind this bringing in the number sense is to not have the child do the inefficient way of counting, which is every single thing is on your finger, right? And so be patient, gently correct any errors as you go on. Integrate that number sense. Remember, it's not only about the right answer. See if they understand any special words. If I said the double, what is the doubling 3 equal to? And they should understand that word double means adding the same amount twice. So doubling 3 plus 3 is 6. So look at those in terms of the interpretation. To play the parking lot game with your kids as you switch things up, get them used to knowing new words, what are even digits, what are odd numbers. Find a particular car, and let's say you tell them we're using the first digit, we're using the first digit of this car. So that's a 7, and depending on their age group or what you want to do, you want to say, I want to add, and you can supply the number that you want to, whether you want the sum to be less than 10, or less than or equal to 10, or greater than 10, it's up to you. All right? So do look around for places where you can get creative with your child. Do not just, every time you go to the living room, that is where you're going to be sitting down and doing all math and homework. All right, the summing of 3 digits is a little confusing, believe it or not, to many children. So let's say that they've moved on, definitely from grade 1 going into grade 2, you're given these, say, 3 digits to sum. Your child will probably write down, or could write down, that the answer is 3 or 6. And why would they write such crazy answers? Well, this is their thinking. They're telling you that, hey, all you have taught me before is that I should add 2 digits, or 2 numbers. So they've taken this sum, 1 and 2 is 3, and said, nobody told me about that 4. I don't know what to do. Or the second solution that I have up there, given these, if they added from the bottom, they might write down that, oh yeah, the answer is simply 6. So that's where their minds are at when they are seeing a sum, a listing with more than 2 digits. Now, what you have to do is to try to let them make sense that, hey, what we're having here is really more groups, right? We have a group with 1, 2, and 4. So in doing this, if I started from the top coming down, you would now be saying, yeah, the first group, 1 and 2, is 3, and now I'm combining 3 and 4 to get 7. Or starting from the latter part here, where they've gotten 6, you're now combining that with your 1, and you end up with 7. So it's, don't think that your child just does not get it. He or she really has. But you fail to explain to him or her that you want him to extend this concept. He or she only knows that you've been telling him add 2 digits at a time. All right. So hopefully some of these will help. As you're driving around, sitting around in the car, talking, you can just do some mental math. Just spew out some numbers. 5 plus 3, what do you get? And, see how quickly they respond and so on. It will also keep you on your toes to see if you are up there mentally. All right. And practice and enjoy your time with your child. It's a great age for you to have them and be able to work with them. And it will remind you of why you should have paid attention to math when you were that age or even a bit older. It's the math teacher's revenge when you have a child and you have to go back through math classes. Thank you for joining us, and I'll see you next time. All right. As always, at the end, I try to bring in a little bit of things regarding Jamaica. The blood types in Jamaica. You should try to know your blood type, and we see, just like the rest of the world, that O positive is the most common blood type. Believe it or not, O positive is a higher percentage rate of being present in the Jamaican population than it does in the world population. The world population is about 37%. And the most rare blood in the world, AB negative, we in Jamaica, we still have a higher percentage than the world population. The world population 0.06%. So I guess if anybody needs to get a donation, then they should really come and think about Jamaica. Oh well. Anyway, so these are the various blood types, and you can, as a parent or so on, you never know. Go ahead and support the blood bank, donate your blood, make a difference, and maybe the life you save is your own, right? So if you're healthy, do give blood. All right. So take care. And this is Dr. G from the Math Clinic.